Today we're going to talk about Quantum Accord member ecosystem, and for the first person presenting today, I want to welcome Viki Forrest, Trade and Investment from Queensland, Australia. So Viki, take it away.
Thank you very much. Welcome, and I'm delighted to be representing Queensland today. I'm actually the Commissioner for Trade and Investment Queensland. But I'm representing the state of Queensland and specifically the Department of Environment, Science and Innovation, who are behind Queensland's quantum strategy. So Queensland has a long history in quantum. We've had leading minds in the universities of Queensland for over 3 decades. And so when my group decided to take a look at quantum here in the US, it was no surprise that whether we were looking at the large corporates like IBM and Amazon or the emerging companies out of Silicon Valley, every company had a Queenslander in it. So those years of leading in the universities in quantum were starting to pay off commercially. Queensland also has strong capabilities beyond the academic. 4 national quantum centres of excellence exist in Queensland, including the first nation-spanning centre for quantum biotechnology. The Queensland quantum capabilities are not just in quantum science specifically, but also in advanced materials and characterization of fabrication facilities. So you'll see there that there's a lot of universities with centres across Queensland that are focused on quantum capabilities. As I mentioned, the strategy that came out of our Department of Environment, Science and Innovation was launched in October last year. It was the first of its kind in Australia, so the state of Queensland is in fact leading the country of Australia in quantum technology. The strategy has 5 pillars, and from the obvious perhaps of the deep science capability, maintaining Queensland's leadership in our position in quantum science, through to investment, through to attracting external investment in Queensland and everything in between, the science, the growth of quantum advanced technologies in the commercialisation pipeline, ensuring we have the workforce to support that, and the workforce indeed to solve the big problems that only quantum can solve for Queensland. We're also very proud of the way we're doing this in Queensland, which is with a very strong Team Queensland approach, led by our Professor Kerry Wilson, who's the Queensland Chief Scientist, and including in that ecosystem not only the universities, which I've mentioned, and and government, which was behind the strategy, but also the venture community, and very importantly, industry. And with that, I would like to invite Tom Stace from one of Queensland's emerging quantum startups to showcase that to the audience.
Thanks, Viki. Yep, sure, I can go there. Well, thanks everybody for coming along. So I'm Tom Stace. I'm a professor at one of the universities in Queensland, and I'm also the co-founder and CEO of the first quantum technology startup in Queensland. It's built on research that I did in one of the Australian government-funded Centres of Excellence, Centre for Engineered Quantum Systems. And I'd also like to some of the photos that Viki just showed of some of the early founders of quantum science and quantum technology that's now turning into an entire industry. came through UQ and started doing this research in the 80s actually. So we've got a very long pedigree in quantum science and technology. So my company, Analog Quantum Circuits, is solving a very specific problem which we have identified in the development of quantum technologies, particularly around superconducting hardware. And so if you look at this picture, this is something that I cribbed off an IBM presentation showing their roadmap, which they published in 2019, and they've hit their targets for qubit counts, and last year they hit 1,000 qubits. And they've also said that they want to hit 100,000 qubits early next decade, which is a pretty standard number for physical qubits in various architectures. But going from 1,000 qubits to 100,000 is a big scaling problem. And there's a number of things that go into a quantum computer, some of which only microwave engineers have ever heard of. So this is a gadget, it's called a circulator. It's about the size of a matchbox. It's a very bulky object, and they cost about $1,000 or $2,000 a pop, and you need roughly one per qubit. So if you've got 1,000 qubits, that's fine. You're IBM or Google, you can afford a few hundred or 1,000 of those. But if you want to get to 100,000 or 1 million physical qubits, you need to spend a lot of money, and you can see just the physical volume is going to be a problem. And so we think that there's a problem, which is a scaling problem, which has an analogy with ENIAC. So if you remember, the earliest digital computer was in the 1940s, going from that room-sized object with engineers plugging cables into racks of hardware to a thing that now fits inside your pocket that's vastly more powerful, was a fabrication and microfabrication and integration challenge, which was solved over decades. And if you look at what a quantum computer chandelier looks like in a dilution fridge, it's sort of human scale as well. And to make a large scale in complexity quantum computer, we need to shrink all the components, including these things that I just showed you, circulators. And just to give you a flavour of the kind of things that we do at Analog Quantum Circuits in Brisbane is we make, develop the IP that we have protected around circulators, and this is the kind of thing we build at home in the labs that are the Australian National Fabrication Facility, the Centre for Microscopy and Microanalysis, and then we measure them in dilution fridges we have in the lab. And this is a gadget that's substantially smaller than a human hair compared to the bulk circulators that I showed you before, but functionally the same. And so that's something that we've made an early generation of our technology that we're working to commercialise. And so that's what we're doing. We're part of the quantum supply chain, and I think that's a critical thing that this Accord can help build. That is the connections between companies like ours and our partners in other geographic domains. So thanks, Viki. I'll pass back to you.
Thanks very much, Tom. And now, Stratton, I'd like you to present PsiQuantum as a great investor, recent investor in Queensland.
Thank you.
Just the green arrow.
Great, thank you. So, I'm the Chief Business Officer at PsiQuantum, and I'm not from Australia. Oh, sorry. 4 of our founders are from, or 2 founders from Australia. We also, Viki showed 2 pictures of Jeremy O'Brien and Jeff Pride, both having done early work in Queensland. And as we'll talk about, Jeff now is leading a lab that we've just announced yesterday at Griffith University for testing calibration of photonic quantum circuits. We've had a simple mission for almost the 10 years now that Jeremy and Pete and Terry started the company: build the first utility scale quantum computers. You'll never see any chandeliers, you'll never see any small systems on their way to being big systems. We've always talked about the need for error correction and fault tolerance, and therefore on the order of about 1 million physical qubits. There's nothing that we've wavered on since then, and we'll be installing our alpha systems at the Stanford Linear Accelerator Complex in about 3 months. We took a fast path. This is what the founding team realized with their work in the UK. Using photonics, you could leverage semiconductor manufacturing and build very, very high scale quantum computers. So we took existing photonic circuits, which have existed for more than a decade in telecom and data center applications, redesigned them so they could have the performance needed for quantum circuits, and then introduce new materials into the semiconductor manufacturing land that would actually give us the efficiency, the loss rates, and the speed that we needed. So redesign the circuits, then integrate these new materials into GlobalFoundries Tier 1 fab in Malta, New York, same fab that is actually fabricating billions of chips now for laptops and cell phones. We sit in that same line and are getting thousands of wafers every year. We've tested over 10 million of our quantum circuits in the last 2.5 years. So innovate where you must, which is our photonic circuits, and then leverage where you can, which is the semiconductor manufacturing chain. The next column is really supply chain. You'll see our components look like transceivers that would fit in a data center rack, right? And so we are building massive racks in a large data center, but you'll be plugging in PCB boards as well as fiber connects and just very, very standard types of computer circuitry. Then you have to build it in the cabinet. Now, our components run at a very cold temperature, about 4.5 Kelvin. Significantly hotter, though, than what you have to do for superconductors at 100 millikelvin or so. So we have the ability to use existing cryogenic cooling powers like you'd find in a Department of Energy lab or at Stanford or in many places around the globe that have particle accelerators or such. That technology's been around for 10 years. We do not have to invent bespoke, exotic cooling technology. Again, leverage where you can. These first cabinets are actually built by a custom manufacturer who builds refrigerators for the beverage and food industry, right? So it's very much existing technology that does not have to be invented. And then last, you have to have a partner that will support you in building a compute site. Our belief is that a useful quantum computer will be a massive data center, very much like what you're going to do with AI data centers and the rest. So you have to have both the utility, the power, the cryogenic cooling, and the support of both the state of Queensland and the Commonwealth to allow us to do that. So as many of you know, in April we announced with the Prime Minister and the Premier of Queensland that we'll be building our first compute site in Brisbane at the Brisbane Airport, and we are very fast on our way to breaking ground here in 2025 with an operational date by the end of 2027. In addition to what we were doing on the ground, we also have now arranged memorandums of understanding with 5 of the universities in Queensland to look at curriculum development, to look at talent and training pools, to set up internships and even support for postdoc programs. We really need to get the talent pool much more elevated than it is in terms of number of people that can do this. So we plan to bring over 400 jobs in the next few years, but much of it training for the skills not only at quantum computing and quantum photonics, but also at supply chain, cryogenic cooling, photonic circuit design, and the rest. We will also be putting a climate center in partnership with Queensland and with some of the universities to develop use cases in quantum computing for climate change. This new lab, as I mentioned, will be live probably in January, February of 2025, and it will be our only test and calibration lab in the world. So it's a very, very important piece for us. And as we are building the first machine in Brisbane, all of that know-how and knowledge is absolutely necessary for us to actually deploy. So, our partnership with Queensland has been great to date. We've started ramping up. We're now at, I think, about a whole 10 people, right, in Queensland. But by the middle to end of next year, we'll be north of 100, building out the facility so that we can build the computer in 2027. Thank you.
Okay. So I'm going to talk about the Quantum Valley in Waterloo, Ontario, Canada. So I'm CEO of one of the organizations that live in the lab, in the valley, Quantum Valley Ideas Lab, and I'll talk a bit about our role in the organization or the community as well. So before I start in our region, I figured I would kind of link it to the bigger Canadian picture so people have some relative understanding of kind of how the Canadian community is organized. So Canada is a big country. So our quantum hubs are fairly distributed across the country. So we have 4 main hubs, one centered around Vancouver and BC, one around Quantum City in Calgary, one in the Waterloo-Toronto corridor. We can talk a bit about that as well, and then one anchored around Sherbrooke in Quebec. So those are really the 4 big hubs, and like I said with my little arrow here, I'm going to speak to kind of the activities in specifically the Waterloo region and the organizations that are part of the community. I want to make one distinction. We are a loosely coupled community. I'm not a member of the government. We don't have a unified not-for-profit that sort of runs the community. We kind of work together as a community. So I'm speaking kind of as a Qville person, but reflecting on what's happening in the Waterloo region. So let me start with a bit of a picture of the community. So Quantum Valley in Waterloo has been sort of growing for at least 20 years. So it was founded through the vision of Mike Lazaridis of BlackBerry RIM fame, where he became a philanthropic investor in the potential of quantum technologies over 20 years ago. And his strategy and the strategy of building the community was to leverage philanthropy with our provincial government and our federal government to start to build, assets of education, academia, research, commercialization, and sort of build out the quantum ecosystem in that region. So Waterloo is sort of anchored around the University of Waterloo, which is one of the world-leading technology universities, engineering, physics, quantum, software, et cetera, et cetera. So that sort of becomes one of the key constituents, and associated with that is the Institute for Quantum Computing, which is one of the lead sort of organizations in our community. And so that's an organization associated with the university, cross-appointed faculty. And then the other main organization that exists in the community is Perimeter Institute, Theoretical Physics, which is going to celebrate its 20th anniversary of being in October of this year. So all three of us, plus this transformative quantum technologies program, kind of have interlinkage on various topics, ranging from the talent development, internships, research collaborations, commercialization activities, and there's a set of other associated institutions that I'll show you kind of as I sort of blow out this diagram. The reason we call it kind of the valley is that all this activity kind of happens within even though we're a big country, all of this activity is happening in like a 5 to 10 kilometer radius around the university. So there's a heavy concentration of principal investigators and academic teams and postdocs and graduate students and undergrads, commercialization activities, startups, accelerators, incubators, all of that with a fairly strong focus on quantum. And that 20-year history, the number I think we use is about $1.5 billion of investment has flowed into, it's probably more, but the best estimate I think is $1.5 billion over those years, building up the infrastructure and the capabilities, the research capabilities and the companies, et cetera, that exist. So that's kind of the high level view. So my organization in that ecosystem, so we are kind of a unique organization in the Canadian landscape. We're an independent, not-for-profit industrial research lab with a mission to accelerate the commercialization of quantum technologies. So we kind of live in this community as an organization heavily focused on taking ideas from TRL 3 to TRL 7, what I would call a commercial-ready prototype, and then translating that idea into a range of startups by licensing our IP. So we've picked quantum sensing because our runway is 3 to 5 years from idea to company and executing as a startup company. And part of our mission is to build a lot of IP. So we've developed over 40 patents in my organization alone over the last 4 years around these technologies, leading some of the activities in Rydberg atom RF sensing, kind of in a global space, and we're commercializing those in our first company. So we live in this ecosystem in a couple of areas, right? So this is where I kind of blew out a bigger picture of kind of the pillars of the organizations that live in the Quantum Valley. And so we are economic development, or Waterloo EDC, which you'll see the logo somewhere here on the government support side, is the regional government's economic development organization. They do publish a version of this. It's a bit of, depending on which day you look at it, it's going to change because more companies get created, stuff happens, right? So I've doctored what's on their site to add in the most recent activities in the community. So it is centered around the research presence of the organizations in the research community. So as I mentioned, the university, the Institute for Quantum Computing, and the Transformative Quantum Technologies program lives around the university. So it's faculty, principal investigators, I think 38 PIs at IQC is the number, with teams of grad students and postdocs, and a whole sort of quantum education stream being executed, including a master's program. And we sort of work with from a talent perspective, we have an internship program in my lab running, offering opportunities for those master's students. So there's a lot of cross-pollination of the activities between the community members. Inside of that research infrastructure is a shared quantum nanofab and characterization facility. You see that logo there, QNFCF. So that's been built up over the years with donations and contributions from the government, et cetera. And so now that becomes a facility for both academic research, and there's obviously company access on a shared services basis. And then, we say my organization lives in there. We do more applied research. There's this kind of range of research activities from fairly deep theoretical research at Perimeter on cosmology and stuff like that. But Perimeter also has a quantum AI crossover lab called PICKLE. The Perimeter Institute Quantum Information Lab, I think is what it stands for. And so there's a lot of good work coming out of there on the intersection between quantum and AI. And actually there's a startup over here under the business ecosystem, Yannick, that kind of came out of that looking at algorithms for financial services, Monte Carlo portfolio optimization. Commercialization and support. Some of us live in both camps because not only do we do research, but we create companies or support the creation of companies. Waterloo University has a very open IP policy. It's inventor-owned. So there's a range of startups that have been created out of that organization, out of the university and associated things. And there's an accelerator attached to the university, a little Velocity. And then there's an incubator accelerator in the region called Communitech that sort of plays a role in helping companies grow and providing those kind of traditional services. The community wouldn't grow without venture capital. So one example is Quantum Valley Investments. So that's Mike Lazaridis and co.'s kind of investment firm focused on investing in some of the quantum companies that come out of the ecosystem, and there's a few that are listed here. And then this would never have happened without a range of government support. So there's kind of regional there is Waterloo EDC, so standard kind of trying to support the growth and expansion of businesses in the region. Our province of Ontario, both in economic development, job creation and trade format, as well as ministries of colleges and universities, funding obviously the universities. Multiple federal agencies. The one that's listed here is what we call a regional development agency called FedDev. They funded us and other programs. And then there's a couple of innovation and kind of infrastructure funding programs. Canada First Research Chairs, Innovation, or CFI, Canadian Foundation for Innovation. So a lot of the capital intensive buildings and kit to go in those buildings are kind of funded through those kind of global access to shared infrastructure type programs. And then on the bottom, last but not least, is all this stuff from research and commercialization and investment and government support leads to a range of companies. Some of them are here at the show, Evolution Q. Some of them spoke at the Canadian Overview today, including me and some of the other ones here. But it's a range of technologies across quantum sensing, quantum computing, quantum communications, quantum key distribution, some supply chain companies, including I think I put Phantom Photonics on here, who are working on quantum LiDAR, software companies working in algorithms. There's each one kind of has a focus, right? Some are very centrally focused on different, application domains. And in one of the ones that's listed there is our company called WaveRide, which is pursuing 5G testing with the technology that we've developed. So that's kind of the big picture of the ecosystem. Sort of that's supposed to be the little picture in the middle blown up, as you can see. And then I just wanted to kind of highlight the way we think of the ecosystem. So if you listen to Michael Rosenblatt from our government, our federal government, talk about this national quantum strategy in the form of these three pillars: research, commercialization, and talent development. I added infrastructure. Well, maybe it's not there, but I added kind of, in theory, there's a layer across all of that, which is kind of this infrastructure that's needed to build the supply chain and build these things that are going to make useful systems. And so we kind of look at a complete ecosystem across all those community members, the foundational institutions, organizations, and infrastructure, the companies that have rolled out of there, the funding, and a very broad but deep set of capabilities in research, commercialization, talent development, and general workforce and community in quantum. So I think this kind of reflects kind of although we are a loosely coupled group, and we don't have a single company driving the community or representing the community. I think we kind of have a community that's the sum of the parts is greater than the whole in terms of leveraging the strengths of the different organizations and their place in the ecosystem. So that is my quick talk. Thanks for organizing the slides, and that is what I hope to kind of convey about Waterloo. Thank you.